Okay, so good morning everyone. So in this lesson we're going to talk about rotated conic sections. Okay, before I start talking about that, I would like us to understand that if you've got say cos, okay, so these are some of the properties that we're going to apply. You've got cos, let's see, so we've got cos A, then we've got plus B. We can actually write this. It's more of an identity. Okay, we can just grab this and rewrite it. So when we write it, we're going to have cos A times cos B, then we'll say minus sine A sine B. Okay, so just take note of that and memorize this, because of course understanding is the prime thing, then memorizing can come later. So in this case, this is something that we need to memorize. Then in case we're having cos, okay, so sine, so that was cos. What if we're having sine? So if we've got sine A plus B, we can actually take this and rewrite it. And when we do, what we're going to have is, so there's an equal sign there, equal. So what we're now going to have is cos A sine B plus sine A cos B. Okay, so I just want you to take note of this, and I just want you to memorize it, because we're going to apply it as we're talking about rotated conic sections. Last time we talked about conic sections, I believe we talked about shifted. Okay, so this here is an ellipse, major axis, minor axis. Okay, so that's just shifted. Then when it hasn't been shifted, it is going to be located somewhere here, like so. Okay, major axis, minor axis. Now with rotated conic sections, we're talking about a conic section that looks something like this. Okay, so it is pretty much the same. It has the same minor axis, major axis, but it has just been rotated. Okay, so now here's the thing. Starting from the x-axis here, okay, moving counterclockwise like so, this angle theta is how much it has been rotated. Okay, so let's do this. Let's focus on some point here. Okay, that has got the coordinates x, so this is y, and then this here is x. Okay, that's got some points x, y. Then the distance from the origin all the way up to that point is r. Okay, then it means this this angle here, okay, this here would be alpha. Okay, then let's assume that now that they've done the rotation, okay, let's assume that the rotation has been done. The point here will still be our point of interest, but in this case the x and y axis will look something like this. Okay, but we don't want to name them x and y again. Why? Because it would be confusing. Okay, because imagine you say this here is x and then this here is y. So instead, let's give them a prime there and a prime there to indicate that they've been shifted. So that's x, x prime, y, y prime. Okay, what about the angle? In this case, our angle is starting from the same x-axis here where it's black. In this case, our angle is starting from the same x-axis here where it's black, and then moving counterclockwise up until we meet this here. Okay, this other x-axis. So starting from here all the way up to there, let's not call it alpha, let's call it theta. In fact, let me put it in red to avoid confusion. Okay, so this here is theta. So what we're now going to do here is this. Okay, let's focus specifically on this box. Okay, the black box. So if I were to draw it out separately here, okay, like so, it will look like this. Now using trigonometry, this here is alpha. Using trigonometry, let's say this here is your opposite, which is y, and then this here is your adjacent. And I believe by now we should be familiar with finding the coordinates of a point. In other words, using SOHCAHTOA, okay, finding the x and y. So in this case, your opposite would be this, which is in the y, and your adjacent would be there, and this is your hypotenuse. So to find the y, would say, since it's so, okay, it would be sine theta. Actually, this isn't theta, this is alpha. So sine alpha is equals to, what is the opposite? Y over the adjacent, sorry, the hypotenuse, which is r. Okay, so what we're now going to do here is this here is wrong. Okay, now why is it wrong? Because all that we've done, remember, I just had to take this out just to give that clear picture. Okay, that clear picture of whatever it is that we're doing. But in reality, we're still having the red rotated conic section, the red xy plane. Okay, so let me just draw it here. Now, as you may see, this red is literally cutting through like that. Okay, so it is not only having alpha as the angle, but it is also having what? Theta as our angle. Okay, and in this case, the theta is starting from the x-axis, moving counterclockwise up to there. Okay, so our theta is actually here, and our alpha is where? There. Okay, so our alpha is here, then our theta is here. Okay, not entirely here. This would be wrong. So with that being said, let us now carry on with whatever it is that we're doing. Okay, so let's carry on. So this here would now be, remember, this here would be wrong. So this would be sine theta alpha plus theta. Okay, alpha plus theta, which is alpha plus theta right there. Okay, opposite, which is in the y, should be equal to opposite over the hypotenuse, which is r. Let's solve for y. So when we cross multiply, this will be y is equals to r sine alpha plus theta. Then we are done. In this case, let me underline this because we'll get back to it. This is very important. Now let's do the same, but for cos. Okay, so this would be x is equals to the adjacent. Okay, actually, let me just write it down in a nice, common way. So this is cos, which is car. Okay, adjacent over hypotenuse. So this would be cos alpha plus theta close is equals to opposite, which is in the y, over the adjacent, sorry, over the hypotenuse, which is r. Now again, the reason why we're using alpha plus theta is because alpha plus theta is what we have here. Okay, it is the combination of the two. This is the angle. Theta is only as far as it has moved, starting from the x-axis, moving all the way up to the red one there. Okay, that's just theta. Alpha is starting from there all the way down up to there. So solving for y, what we're going to have is, actually this is x, it's the adjacent, yeah, over 1. When we cross multiply, this would be x is equals to r cos alpha plus theta. Okay, let me also underline this. This is very important. So remember what we discussed in the previous, actually, yeah, so we're done with this. Let me take this and leave it where it is. Okay, now let's go back to our diagram. What we're doing here is finding the x and y coordinates specifically for this. Okay, the black the black cube there. Okay, now let us shift our interest from the black cube to the red one, and when we do, what we're going to have is this, from this black triangle right here. Okay, from this black triangle specifically to this red one right here. Okay, which came something like that there, like so. Okay, when we look at our diagram here, so this also has its x, its y, and its x. Okay, as you may see, yeah, so that's what it looks like. So let's shift our focus to that now. So at the top here, what we had as our angle here was alpha. Okay, let's maintain that. So this comes like that. Okay, like so. I hope we've gotten the logic there. Okay, all that I've done here is this. If this here is your angle, then it looks like that. If it has been shifted, it will be like so. Okay, so the same thing, but just pay close attention to the diagram lest you get confused. So moving on, this blue here, okay, that's alpha there. Okay, so let's find its x and y coordinates. But remember what we discussed, let's not call it x and y. Instead, let's call it alpha. Sorry, let's call it x, y, and y, x prime and y prime. So what we're going to have is this. Taking this same triangle and then removing it, this is alpha. So using the same trigonometry, this is so, okay? Opposite hypotenuse for r. So this would be sine alpha is equals to, what is the opposite? Y prime, okay? This here is y, this here is y. This here is x, this here is x, okay? So that would be y prime over adjacent, sorry, this sine alpha is equals to y prime over the hypotenuse, which is still r. Let's solve for y prime. When we do, y prime would be equal to r sine alpha. Let's underline that. It's also important. We'll get back to it. Let's do the same, but this time we do it for cos, which is the adjacent right there. Remember, at first, let me use a different color. Let me use green. At first, our interest was in this cube, okay? And then we just had to get this triangle right here. But because it has now been shifted, our interest has also been moved to this triangle right here, okay? Yeah, so with the first one, it had both alpha and theta in it. That's why we said plus. Then in the second one, it only has alpha, okay? Here, I bet we've seen it by now. So y prime, this is sine, yeah. So solving for, we've got sine alpha, solving for y. Underlining it, that's what we have. Then for cos, it is just going to be x prime is equals to r cos alpha. How did we find cos? Adjacent. So this is adjacent over hypotenuse. In this case, our adjacent is in the x. Our hypotenuse is y, r, sorry. Yeah. So we're done. Okay. Now what can we do with these equations? What about them? Okay. How can we make them useful? Remember, we've got this one here, we've got this one here, we've got this one and this one. Okay. Remember what we discussed at the beginning of this video. Let's focus on x first. Okay. This here is x is equals to r cos alpha plus theta. Remember, take this as your a, take this as your b, and then let's do what we did at first at the beginning of the video. I kindly pause the video and try to rearrange this, factor out the r. For now, do not focus on the r, just focus on the x and the theta. So in fact, let's factor it out. So this is r, then this will be cos alpha plus theta, okay, like that. Now, according to what we discussed at the beginning of the video, this is expected to be cos alpha cos theta minus, okay, sine alpha sine theta. Okay, so now what we're now going to do here is multiply this r with everything inside. So when we do, what we're going to have is r cos theta cos alpha. So I believe you get the idea here. Said the right thing, said the wrong thing, did the right thing. And then this r multiplying with that, what we're going to have is r sine alpha sine theta. Okay, sine theta. So let's take a very close look at this. Okay, let's take a very close look at this. What is r cos alpha? Remember, we had drawn it here, r cos alpha, which is x prime. So in this case, let's replace r cos alpha with x prime. So this is going to be x is equals to x prime cos theta minus, let's also look at this. This is r sine alpha. And according to what we had done here, r sine alpha is equal to what? Y prime. So let's draw our y prime there. Write our y prime there. So that's y prime sine what? Sine theta. Okay. So for now, let's skip this equation as well. Okay. It's not amongst the four ones which we've done, but it's very important. Okay. These four, 1, 2, 3, 4. Okay. let me just draw them nicely. 1, 2, 3, 4 are very essential in helping you finding out these two main equations. So there's this one. Now let's do for y as well, okay, which is for sine. And in this case, it is going to be this one right here, okay. All this which we've done here came from this, okay. We just got this, we had to expand it, okay. Now let's grab this and then we do the same. So grabbing it, let me just zoom in a little bit. Grabbing it, so let me just memorize this. Y is equal to r sine alpha plus theta. Okay, so y is equals to r, open brackets, actually r sine alpha plus theta. And doing the same thing that we did at the beginning of the video, and taking this as your a, taking this as your b. Okay, let's factor out the r. So this would be r, we open brackets, this would be sine theta, sorry, alpha plus theta, we close brackets. Okay, now let's expand this and take it to a different form. Okay, now what we discussed was this: y is equals to r, we open brackets, then we say cos alpha sine theta plus, okay, this time it's a plus sine alpha cos theta. So what we're now going to do is just multiply the r. So we'll have r is equals to r, sorry, y is equals to r cos alpha sine theta, okay, plus r sine alpha cos theta. So this is actually, we're not done yet. So let's take a look at those two equations, okay, these ones right here, this one and this one. Okay, this is y prime is equals to r sine alpha. Let's look at this equation right here. What we have here is r cos alpha. Okay, what is r cos alpha? R cos alpha is y prime, sorry, x prime. So let's replace that with x prime. So this is y is equals to r, actually just x prime, sine theta plus, then let's take this, okay, let's take a look at this. Don't target the ones with theta, target specifically the ones with alpha, then replace them. So that's r sine alpha. So what are we going to do there? Let's see, r sine alpha here, okay, which is y prime. So this here is going to be y prime cos theta. Okay, so this is our other main equation. So we've got this equation and this equation. Remember, it would be more convenient if you were to write this one, that one, and this one somewhere there. Okay, 1, 2, 3, 4, just somewhere separately. Okay, because these are the ones that are going to help you. Because those are the ones that are going to help you find these other main equations. Okay, so for now, let's just take note of these equations and then write them down separately somewhere, and then we get back to them. Okay, these are the two main equations. Yeah, so these 1 and 2 are the two main equations. Okay, the rest will only help you out. Please, let's not memorize. What's important is we've understood. Okay, now here's the thing: how can you be able to understand and see that, okay, this conic section is not necessarily rotated? Okay, how can we identify that? Because sometimes people might tend to expect to see a parabola, an ellipse, when in reality they're going to find a circle. So how can we notice? Okay, so let's do this. Write down your a. Let me zoom in a little bit. Write down your a, okay, then you skip b, then you say plus c. You just leave enough space, okay, plus d, so there's no enough space there, plus d, plus e, plus f should be equal to what? 0. Okay, so now what we're going to do is, remember we've skipped a b. Okay, what I'm now going to do here is this: write x squared y squared. Okay, then you say x y. If your equation looks like this, okay, before you start taking out your before you start using the difference of, not the difference of the squares, actually, yeah, before you start taking the, yeah, before you start evaluating your equation, okay, as we discussed in the previous videos, if you watch them, before you start taking all these, how can you know that okay, this here is not a shifted conic section? Let us do this, no, not shifted, rotated, sorry. Let us do the same thing which we've done, but this time let us add b. So we're going to say a plus c plus d plus e plus f should be equal to 0. Okay, yeah, so should be equal to 0. So this is going to be x squared, then this here is going to be actually plus b. Yeah, we should have put b plus b. Okay, then this would be y squared. We carry on with what we did. Then this is going to be x y, but while there's b here, let us put x y. Okay, so that is how you would know that your conic section is not what is rotated, if it has a b there. What I mean by that is this. Okay, you may have an equation which is 3x squared plus maybe 8x, no, not x, let's say y. Okay, 8y squared plus maybe 5x plus 2y plus 8 should be equal to 0. Okay, this looks like this. Okay, why? Because this would be your a, this here would be your a, this would be your c, this would be your c, this would be your d, this would be d, e, f, f. Okay, now of course they may not put it in this favorable order, but they may be jumbled, but just ensure that you put them in this order so that when you notice that there isn't a value here that is maybe at a 3, then it has xy. Okay, if it has such xy, then you should know saying that this here is a rotated conic section. So you need to find a way of removing this. So that is what we're going to discuss in the next video. Okay, and how to take this out. And when you take it out, that's when you can be able to solve your equation.